Imagine a world without refrigeration, a world where fresh food spoils quickly. Refrigeration, while often overlooked, is the invisible backbone of our modern society. It's the silent guardian in our kitchens, preserving our food and keeping it fresh. It's the unsung hero in hospitals, safeguarding life-saving medicines and enabling complex surgeries. Refrigeration's impact extends far beyond our homes. It underpins global food supply chains, allowing for the transportation of perishable goods across continents. It's crucial for various industries, from manufacturing and pharmaceuticals to technology and research. Refrigeration, in essence, is more than just about keeping things cool. It's a testament to human ingenuity, a triumph over nature's tendency towards decay and entropy. Refrigeration may seem like magic, but it's rooted in the fundamental laws of physics, specifically thermodynamics. Heat naturally flows from hotter objects to colder ones, like a ball rolling downhill. Refrigeration, however, does the opposite. It moves heat against its natural inclination, from a cold space to a warmer one, much like carrying the ball uphill. This feat is achieved by harnessing the power of refrigerants and manipulating their physical properties. Imagine a refrigerant as a diligent worker carrying buckets of heat. It absorbs heat from inside the refrigerator, making the interior cold. The electricity powers a compressor, the engine that keeps the refrigerant flowing and the heat moving, ensuring your food stays fresh and your ice cream remains frozen. Refrigerants are the unsung heroes of the cooling world, the workhorses that tirelessly ferry heat away from our food and medicines. These substances, often liquids or gases at room temperature, possess a unique ability to absorb and release heat at specific temperatures. Think of a refrigerant as a sponge, soaking up heat in one area and releasing it in another. When a refrigerant evaporates, it absorbs heat, just like sweat cooling our bodies on a hot day. Conversely, when it condenses, it releases the absorbed heat, much like dew forming on cool grass at night. Early refrigerators used refrigerants like ammonia and sulfur dioxide, which were effective but also toxic and flammable. The discovery of chlorofluorocarbons, or CFCs, in the 1930s revolutionized the industry, offering a safer and more efficient alternative. The quest for artificial cooling dates back millennia. Ancient civilizations, from the Egyptians to the Romans, used ice harvested in winter and stored in underground ice houses to preserve food and cool drinks. The invention of the first vapor compression refrigeration system in the 18th century marked a turning point. This system, though rudimentary by today's standards, laid the foundation for modern refrigeration technology. The 19th and 20th centuries witnessed rapid advancements in refrigeration technology. The invention of the electric motor led to the development of the first practical refrigerators for home use. Refrigeration transformed the food industry, enabling the safe transportation and storage of perishable goods over long distances. Today, refrigeration technology continues to evolve at a breakneck pace. Refrigeration is more than just convenience, it's a powerful tool for combating food spoilage and ensuring food safety. Food spoilage, caused by microorganisms like bacteria and fungi, leads to food waste and foodborne illnesses. Refrigeration slows down these microorganisms, pausing nature's decomposition clock. Keeping food between 32 degrees Fahrenheit and 40 degrees Fahrenheit extends shelf life and reduces foodborne illness risks. Different foods need different storage temperatures and conditions. Fruits thrive in humidity. Meat needs to stay dry to prevent bacteria. Modern fridges have specialized compartments for optimal food conditions. Refrigeration's impact extends far beyond food preservation, reaching into medicine, scientific research, and various industries. It's a silent force enabling life-saving treatments, groundbreaking discoveries, and supporting industrial processes. In medicine, refrigeration is crucial for storing vaccines, blood products, and temperature-sensitive medications. Vaccines require precise temperature control to maintain efficacy. Refrigeration is vital in organ transplantation, preserving organs until matched with recipients. Beyond medicine, refrigeration is indispensable in various industries. While refrigeration has brought undeniable benefits to our world, it hasn't come without its share of environmental consequences. The early generation of refrigerants, particularly chlorofluorocarbons, CFCs, were found to have a devastating impact on the ozone layer, the Earth's protective shield against harmful ultraviolet radiation from the sun. CFCs, once hailed as miracle chemicals for their stability and non-toxicity, were found to be potent ozone-depleting substances. When released into the atmosphere, they rise to the stratosphere, where they break down under intense ultraviolet radiation, releasing chlorine atoms that react with and destroy ozone molecules. This discovery, made in the 1970s and 1980s, led to a global outcry and a concerted effort to phase out CFCs. The Montreal Protocol, an international treaty signed in 1987, is considered one of the most successful environmental agreements ever, phasing out the production and consumption of ozone-depleting substances including CFCs. While the ozone layer is slowly recovering thanks to these international efforts, the environmental impact of refrigeration hasn't gone away. The challenge for the refrigeration industry today is to continue to provide the cooling solutions we rely on while minimizing their environmental impact. This push for sustainability is driving innovation, leading to the development of greener refrigerants, more energy-efficient appliances, and alternative cooling technologies. One promising avenue is the development of natural refrigerants, which are substances found in nature, like hydrocarbons, propane and butane, carbon dioxide, and ammonia. These refrigerants have negligible or zero ozone depletion potential and a much lower global warming potential compared to HFCs. Another area of innovation is in the design of more energy-efficient refrigerators and air conditioners. Advances in compressor technology, insulation materials, and defrosting systems are all contributing to reducing the energy consumption of cooling appliances. Smart features like occupancy sensors and adaptive defrost cycles further optimize energy use, making modern refrigerators far more efficient than their predecessors. Beyond traditional vapor compression refrigeration, researchers are exploring alternative cooling technologies like magnetic refrigeration, thermoelectric cooling, and evaporative cooling. Refrigeration, while essential for modern life, is not equally accessible to everyone. In many developing countries, particularly in rural areas, access to reliable electricity and affordable refrigeration is limited, leading to significant challenges in food preservation, healthcare delivery, and economic development. The lack of refrigeration, often referred to as the cold chain gap, results in significant food losses, especially for perishable goods like fruits, vegetables, and dairy products. This not only impacts food security and nutrition, but also represents a substantial economic loss for farmers and producers. In the healthcare sector, the lack of reliable refrigeration poses significant challenges for storing and transporting vaccines, blood products, and other temperature-sensitive medications. This can hinder disease prevention efforts, particularly in remote areas where access to healthcare facilities is already limited. Addressing these challenges requires a multifaceted approach, including investments in rural electrification, development of affordable and energy-efficient refrigeration technologies, and capacity building in cold chain management and logistics. The future of refrigeration is brimming with possibilities, driven by the need for more sustainable, efficient, and intelligent cooling solutions. As technology advances, we can anticipate even more sophisticated refrigerators that not only preserve our food, but also enhance our lives in unexpected ways. Imagine a refrigerator that can automatically order groceries when supplies run low, suggest recipes based on available ingredients, or even provide nutritional information about the food inside. With the advent of the Internet of Things, IoT, such smart refrigerators are already becoming a reality, seamlessly integrating with our connected homes and lifestyles. Beyond smart features, the future of refrigeration will be shaped by the quest for sustainability. We can expect to see wider adoption of natural refrigerants, more energy-efficient appliances, and innovative cooling technologies that minimize environmental impact. Solar-powered refrigerators, for example, offer a promising solution for off-grid communities, bringing the benefits of refrigeration to areas with limited access to electricity. In the grand tapestry of human ingenuity, refrigeration may not occupy the most prominent or glamorous position, but its significance to our modern world is undeniable. It's the silent guardian in our kitchens, the unsung hero in our hospitals, the invisible hand that shapes our lives in countless ways. From preserving our food and safeguarding our health, to enabling scientific breakthroughs and supporting industrial processes, refrigeration's impact is far-reaching and profound. So the next time you reach into your refrigerator for a cold drink or a fresh meal, take a moment to appreciate the marvel of modern science that made it possible. Refrigeration, though often overlooked, is a cornerstone of our modern world, a testament to human ingenuity and a technology we can't imagine living without.